Multipass is a tool for creating and managing Ubuntu Linux virtual machine. So think of it as a fast and easy way to launch virtual machines, that is virtual computers inside your computer, that you can use for testing, learning and hacking, all from your terminal and also from the GUI. So this is the Multipass graphical interface. And so this is designed to create virtual machines. You can run this on Mac, Windows and Linux, and you can create virtual machines from here. For example, this is the Multipass program. I can go to instances and you'll see there is no instance here. So we can create a new instance. If I click launch in the main screen, you'll see it's starting to launch the image. And then I can go to instances and we have one image starting. I can click on the name and you see it's still initializing. This may take a moment. And we have the button Open Shell. If I click Open Shell, we now have access to a Ubuntu Linux terminal. So you'll see here Ubuntu Linux, and that is on top of a Mac computer. So you'll see here the typical Mac dashboard or the Mac dock with all the Mac stuff. And inside it is a window with a Linux computer, a virtual computer. So there's no two computers. There's a simulated computer, a computer inside a computer. So this technology works on Windows, Linux, Mac, and this allows you to quickly create a virtual machine. So we can run all kind of Linux commands. For example, you name this A, and it will tell you the system. You can check your username and run whatever Linux commands you want. Now, this time we manage this with the GUI, but we'll also take a look at how to manage this with the command line. But the general idea is that you can create one or more virtual machines. Now, in the case of Multipass, it's only using one system. So there's only Ubuntu Linux. It doesn't virtualize any other system. So this doesn't allow you to run Windows on top of your system or Mac or another types of Linux. It's only Ubuntu Linux with Multipass. However, it's still a good tool because it allows you to quickly get a Ubuntu terminal, a Linux terminal that is very lightweight. If you want to play with virtual machines but keep it simple, Multipass is the answer. I'm going to show you how to install Multipass on Windows. It will be super easy and super fast. So first we'll go to the web and we'll search for Multipass. You'll see this website pop up from Canonical. That's the creators of Multipass. If we click on it, we end up in this website. And from here we can click Install Now. We'll select Windows. And you'll see a link, download Multipass for Windows. So this allows you to download Multipass. Now this takes a moment to install. And we can click Next. And Next again. You can choose which hypervisor you want, so that's the underlying system. You can simply use the default one, or if you want, you can use the other one. Now make sure to add it to the path, so it could be all users or the current user, depending on what you prefer. So in the directory where to install Multipass, and then click Install. So it will take a moment to install. And you see it's installing Multipass software, and this will allow you to run the Ubuntu Linux system. And you'll see you might need to restart Multipass for it to work. Now that it's installed, you can run Multipass. You'll see we have an app, Multipass. We can minimize this. And from this, from here we can create virtual machines. So these are virtual computers that you can run either where you can run a Ubuntu Linux system on top of your Windows computer. We can run different Linux systems. So different Ubuntu-based Linux systems. You'll see different versions, 24. LTS stands for long time support. So they are updating that once, and the others, they are without long-term support. And you can go back quite a lot, so version 16, and there are different versions available. And to run one, we have this option settings. You can choose how much of your processor you want to use, how much memory, and how much disk space. You might want to connect to the bridge network. You can connect some local folder if you want, but we'll keep it simple for this example. I click launch. That will create a virtual machine. So as if you have a second computer, it will create a second Linux computer. And if it is enabled in your BIOS, so you want to make sure that it's enabled in your BIOS, and you'll be able to run Ubuntu Linux on top of your Windows computer. And it will be just a terminal interface, but it will be Ubuntu Linux as a virtual computer on top of Windows. You can create a Multipass virtual machine or a Ubuntu Linux virtual machine directly from the command line. So that would have your own Linux sandbox where, in theory, malware or any bad activity cannot escape the computer. So how do we do that with the command line? So to check if the Multipass is installed, we could type Multipass version, press enter, and make sure you have no typo. So that's Multipass version. If it is installed, you'll see this or some output similar to this. So let's create our first virtual machine. We can do it with a single command. Multipass, launch, -- name, and then the name of your virtual machine. So this can be any name you want. So I'll name it example VM. And make sure that there is no underscore, it doesn't accept it. So it's creating an example VM. So a virtual machine is now being created in the background, but it will just be created. You won't actually see the terminal yet, the Ubuntu Linux terminal, because it's just creating it. It doesn't start it. So it's as if it's installing a computer, but it's not like giving you the screen or the interface to interact with it. So this might take a moment, and you'll see it's launched. We can see all the VMs with the command multipass list. So in this case, there are 2 virtual machines. So we see the names, we see the state, are they running, paused, or stopped? We see the network address of the virtual machine, so each has their own network address, and the image, so the system version. In this case, both are the same version. Now with Multipass, this can only be Ubuntu Linux, no other Linux distributions, no other types of Linux, no Windows, no other systems. It's just Ubuntu Linux. Okay, so how do we access this virtual machine? So we can type multipass shell followed by the name of the virtual machine. So in this case, example-VM, paste it in, and then now we are inside the Ubuntu VM, inside the virtual machine. You'll see here Ubuntu and some output, some default output. You see here, welcome to Ubuntu Linux. So now we have access to a Linux computer directly from our Mac system. So we might try the command lsb release -a or uname-a to show the system information. Now, if you want a fancy output, you might also try fetch or neofetch. And it's not installed by default, but if you install it, you'll get a nice logo with the system information. You can install it with this command. So that's sudo apt install neofetch. And once that's installed, you also see a nice logo with the system information. So that's not installed by default, but it's a nice little gimmicky tool that gives you some more information about a system. And in this case, there's only Ubuntu Linux, so it will tell you Ubuntu Linux. If you run it, you'll see in the logo of the, in this case, Ubuntu Linux, but with the neofetch tool, it depends on which Linux system you're running, or even Windows or something else. So we see the version, and it tells us also in this case the host, so we know it is running in a virtual machine. It tells you the system version, how long it's been up, how much software is installed, and some other information. So we have access to a Linux computer now, and we can run all kinds of commands, all kinds of Linux commands in here. So we just install some software. We can install any Linux software with the sudo apt install command, so whatever software you want to install, you can install. You can create directories. You can list all the files and folders. We have the example directory, and all the Linux commands work now. So now that you know how you can create a virtual machine, how do we stop it? So we can type exit, and we are back in the host interface. In this case, the host is a Mac computer. You see, it's a Mac, and we could list the virtual machines again. So we have 2 virtual machines running. We can type the command multipass stop with the name of the VM, in this case example-VM. So that will stop the virtual machine. If I list again, it's now stopped. Then if you want, you can remove it by typing delete. That will delete the VM. So it's now deleted, but you'll see it's still there, right? Its state is deleted, but we still see it. So we also want to type the command purge. Or sorry, it's just purge without any name. And then if we list it again, the other VM is completely gone. Now you could remove the other one as well if you want. And alternatively, of course, you can do the same thing with the GUI. So in this case, you have learned how to use multipass in the terminal, how to create a Ubuntu Linux VM, and how to manage it, and also how to access it and control it directly from your terminal. Ever wanted your own army of virtual machines, like having a bunch of mini computers inside your computer? So that could be perfect for testing malware or other purposes without burning your real machine. So today we're going to create multiple virtual machines using Multipass. It's the easiest way to spin up Ubuntu Linux VMs like a pro hacker. So in case you haven't installed it, first install Multipass. So to check if it's installed, you can run this command. You will see it is installed. Now let's launch 3 different virtual machines. Each virtual machine will be a clean Ubuntu machine, as if you have 3 physical Ubuntu machines, 3 physical Ubuntu Linux machines. So in this case, there will be 3 virtual computers, 3 virtual machines. So we do that with multipass launch --name VM1. That will create the first one. It takes a moment. And then we do the same for machine 2 and machine 3. So it will create 3 isolated VMs. They don't know about each other, and they are independent of the host computer. Independent in this case of Mac. You'll see I'm running Mac below. And these VMs will exist in virtual space. You'll see that created the first one. We create the second one with the same command. So we only change the name. So that will create the second one. And in a second, we'll create the third one, 3 isolated virtual machines. So we can see it in Multipass. Actually, we have VM1 running. It's creating VM2, and it will create virtual machine 3. Once this is completed. Now, you'll see it does take some time for it to complete. But you will have 3 individual Linux machines that you can use, for example, for malware testing or for other purpose like hacking or experimenting with different setups, maybe hacking into the Linux machine or trying different cybersecurity purposes. So they will really be like Linux machines that exist in virtual space on your computer. But with Multipass, they are all Ubuntu Linux, so they're not other Linux-based systems. Okay, so let's list actually our systems with that Multipass list. And you'll see we have 3 different VMs, VM1, 2, and 3. Those were the names we gave. They're all running. So with Multipass, it's not so memory consuming. You can easily run many different Linux systems. They have a unique internet address. So you'll see different internet addresses. And here we see the Ubuntu version. So we have Ubuntu Linux 24 for all of them. Now it does support different versions of the Ubuntu Linux system, but it doesn't support other systems, other Linux-based systems. Now, what if we want to access one of these computers? Well, we can type the command multipass shell, and then the name of the VM. In this case, for example, VM1. And make sure there's no typo. And we instantly are inside that virtual computer. You see it outputted a lot of text. Welcome to Ubuntu, and so on. Now we can run Linux commands. If you want any kind of Linux commands, we can, for example, list the files and folders. We could create some file. So now we created a file hello.txt. Now let's exit this virtual computer. We simply type exit. If we list the VMs again, you'll see we have another VM and virtual machine 1, 2, and 3. So let's access virtual machine 2 and see that the file is not there because we created it in virtual machine 1. So we enter virtual machine 2. We list the files. There's nothing there. Let's exit this machine. We go back to virtual machine 1. And you see the file is still there. So they are really like different virtual computers. Now, how do you stop these virtual machines? So if we type multipass list, we see those different virtual machines and they're all running. How do we stop them? Well, we can type the command multipass, stop, and then the VMs you want to stop. So now it's stopping all 3 at once. Of course, you can stop them one by one if you want to. But stopping, it really means power down. So taking off the electricity, essentially. If we list them again, you'll see they are stopped, but they're still there. They are not deleted. Now, if you want, you can delete them as well. You can say multipass delete. The name of the virtual machines. So in this case, VM 1, 2, and 3. Press enter and they are deleted. And then the last command you want to do is multipass purge, to really get them removed from the computer. Then if we list the virtual machines again, you'll see we only have the original one if you had one, or you would see an empty list here. So this is the coolest part. Each VM is completely isolated from the other. So if you would run a malware in one of the virtual machines, it doesn't affect the others or your host. So it's like a safe box for running malware, doing hacking, or just testing out different cybersecurity things without too much risk. Now, some malware is really smart, so you want to be careful with it. Some malware can break out of a virtual machine, but that is really, really advanced malware. But it can be useful, like if you just want to fiddle around with Linux systems from whatever system you're using. For example, here I'm on a Mac. If I would want to play around with Linux, I could simply run a multipass virtual machine. If you want to try out different cybersecurity, if you want to practice hacking different Linux computers, there's all kind of purposes that you would use these virtual machines. But once you delete those virtual machines, it's gone. It's like a clean state every time. So there you have it. You just learned how to create, manage, and delete multiple virtual machines in Multipass. Ever needed to send a file into a virtual machine? What if I told you it's as easy as drag and drop, but in the terminal? So this is specifically for Multipass. Let's break it down. First, make sure you have a virtual computer. You can type that with the command multipass launch -- name and then the name of your virtual machine. This can be any name. So this will create the virtual machine if it hasn't been created yet. You'll see in my case it's already created. We can verify that it exists. So if you type multipass list, you will see the virtual machine exists. Then we can share the folder. So in this case, we have this folder here, a folder with this file inside it. Let's share that. Now to share it, we type multipass mount, then the name of the folder. So the name of the folder that you want to share, and then where it has to be found inside the virtual machine. For example, you can say vm1:/home ubuntu shares. Now, if I press enter, you'll see it mounts it. It connects this folder that I have on the host computer, on the Mac computer, to the virtual machine, to the computer that is the Ubuntu Linux computer. So now it is connected. And let's actually see that. So we'll enter the virtual machine with this command, multipass shell, and then the name of your VM that will enter the virtual machine. Then if we list the files and folders, we have a folder shared. You can enter the folder, and if we list it, you'll see it has the same image here as we have in the file manager. So if I would, for example, copy it, you'll see they are connected. I can list them, and now we have two of them. If I delete it, of course it will be gone. So I delete it, list the files, and it's gone. Now we move up a folder and list again. You'll see we have the folder shared. That is the shared drive. So we can now copy and paste files. Now you might wonder, okay, we can do it from the host computer to the VM. What about the other way around? So let's say we create some file here using the touch command. And you'll see we created it on the Ubuntu Linux computer, but it is also immediately available on the host. So this is the way you can share files easily between your real computer, your physical computer, whether that's Mac, Windows, or another system, and your virtual Ubuntu Linux computer. So it's a very easy way to transfer files back and forth. What if you want to send a file and not share a whole folder? That could be a situation as well where you don't want to share the entire folder. So to simply send a file, first you need to be in a folder that has the files. Then you can type multipass, transfer the path to the file, or simply the file name, and then where it should be stored. So for example, VM1, and we want to store it in home Ubuntu, and press enter. And now that file is being transferred from in this case, the Mac computer, from the host into the virtual machine. Now we are not in the virtual machine. You'll see here MacBook share. So we enter it, multipass shell VM1. Now I list the files and folders, and you'll see the file is there. So we just transferred from our host computer to the virtual machine. So if you want to transfer a single file, you can do that like this, instead of sharing the entire folder. It depends on your preferences and the security of your system. Let's say you have some VMs. So if you type multipass list, you might be in the situation where you have one or more VMs. Now we could add another one. Let's say VM3. We'll add another virtual machine, and things can go wrong inside Linux computers, just like in any computer. Inside a virtual computer, things can go wrong. Maybe something breaks or something like that happens. Now, with multipass, you can go back in time. You can create a snapshot, and using that snapshot, you can then restore it to an earlier point where the system was still working. So we have a virtual machine. If I list them, you'll see we have VM3 that is in a state of running. Now in a state of running, you cannot create snapshots, so it has to be turned off. We can enter the VM if you want to. So multipass shell VM3, then we're inside the Ubuntu Linux computer. We can play around with all kinds of commands. Now let's say things go wrong inside the VM. Let's say the VM is hacked. Let's say this VM is hacked. Now we can exit this. And we know that we have those VMs. Now, to create a snapshot, the first thing you want to do is to turn it off. So we can type multipass stop VM3. That will turn off the virtual machine. Then we can create a snapshot by typing multipass snapshot VM3. So that takes a snapshot of your virtual machine. And now let's say you keep using it, and then at some point things really go wrong. And you can go back to now, when you just created this virtual machine, by typing multipass restore and then the name of your snapshot. Now press enter. It will ask you if you want to restore it and if you want to keep the current state. So type no, and then the snapshot is restored. So we can now you can now then use the virtual machine as if the bad event never happened. So just like in any system with snapshots, you can go back in time to your snapshot when your computer was working fine. On a sandbox or a virtual machine for security reasons. So you could have a virtual machine, in this case in multipass, we have one machine that we can enter. And you might do that for security reasons. So now you have a Ubuntu Linux machine and it's running as a virtual computer. It doesn't affect your host. But malware these days is quite smart. Sometimes it tries to detect that it's running in a virtual machine and behave differently, or even tries to escape the sandbox, even tries to escape the virtual machine to get into the host level. So depending on the malware, some malware is quite advanced and it tries to break free from your virtual machine. So how does it do that? We're going to investigate how malware can detect that it's running in a virtual machine. So in this machine, we can run several commands. For example, could get the system information. No, this doesn't tell you anything about it is running in a virtual machine. Might run some or browse different folders. But there is one specific command that it might output the system, and that is this command, sudo dme decode with the system manufacturer. If you run this command, it tells you that it's running as QEMU or emulation. So in this case, that's how it knows that it's running a virtual machine. A program could simply run this command as administrator, and if it returns this, then it knows that it's as a virtual machine and it could behave completely different. So it can know if the malware can actually know that it's running inside a virtual machine and then change its behavior so that the software seems completely innocent inside the virtual machine, so that when an analyst, someone wants to analyze the malware, it doesn't seem to do anything because it detects if it is running as a virtual machine and then does a completely different behavior. It knows that it's being watched. Now, to break out of the machine, it could, for example, start scanning the network. So it could start could use AAP scan. And in this case, it's not installed, so it might install that. So it might install that software and then start scanning other machines on the network. So it's scanning other machines on the network. Now it knows those machines, and then the script itself could try to hack those machines and then get access to the other machines in the network. So this is called pivoting. So using the virtual machine, it tries to find out other computers on the network. In this case, it found 3 computers. You'll see 3 lines here. And then it starts to attack those. So that could be using different types of attacks. It could be a password attack or something more advanced. And then in that way, it can break free from the virtual machine and access either the real computer, the host computer, or other computers on the network. So it tries to spread itself. So just because you run it inside a virtual machine, it doesn't always mean it's safe. Especially what you could do is put your virtual machine in another network so that your real network is unreachable. But besides that, keep in mind that whatever you run in the virtual machine might behave differently in the sandbox because it can detect. For example, with the command we ran earlier, it could detect that it's running as a virtual machine. And then if it's running as a virtual machine, it does a different behavior. Okay, so let's do a demo. And here we have a script malware.sh shell script. See, small shell script of only a few bytes. And if I run this script, you'll see the script itself detects that it's running inside a virtual machine. So if I run this, you see the script detects it's running in a virtual machine, in a QEMU virtual machine, and then the behavior could be completely different. Now, if I have a similar script inside the Mac computer, so you'll see this is a Linux computer, the virtual machine. See Ubuntu. If I run this command, you'll see it's the Linux Ubuntu system. If I open the tab here, this is a Mac system. You'll see here MacBook. Now, if I run the scripts, you'll see that this one detects that it's not inside a virtual machine, or it's a completely different virtual machine. So it's actually, the script actually finds out that, our script can actually find out if it is running in a virtual machine or if it is running as the real computer. So let's take a quick look at the code. So this is the Linux version, and you'll see it just checks if that software is installed, that command. Then it runs that command here, stores the output in a variable, and then depending on if that variable is QEMU, it's in the virtual machine or it is not. So you'll see here if it does one behavior, else it does this behavior. So depending on whether that software is installed or not. So this command is Linux specific. So for the Mac version, it's a quite slightly larger program. So let's take a look at the Mac version. It's slightly longer version. It detects the operating system as well, but it does the same thing. This is the Linux version. You'll see it stores it in the variable and detects if it is in the virtual machine or not. And for the Mac version, it's the same thing. It gets the manufacturer. If it is running in QEMU, we know it's running inside the virtual machine. Otherwise, it is the real Mac. So in this case, if we run it, you see it's running any Mac. So the key point here is that malware these days, sometimes it can detect if the software is running in a virtual machine or not, and does different behavior depending on that. Or even it could try to break free from the virtual machine if it knows it's inside the virtual machine to get access to other computers on the network or to your host machine. We have a list of different virtual machines. So we have the names of the virtual machines, the network address, the images, and so on. Now, the idea, of course, with these VMs, these virtual machines, is that if you enter a virtual machine, it doesn't affect any of the others. However, that isn't always the case with malware. Sometimes malware tries to break free from the virtual machine and try to get into the other machines. For example, here we have some machines. We have virtual machine 1 and virtual machine 3, as well as some others. And they have a unique network address, a unique IP address that's unique to those virtual machines. Just like your home has home addresses, the virtual machine has a unique IP address. So each one has a unique IP address. So let's say you are inside one of these virtual machines. So let's see, we can actually enter them. I can say multipass shell VM1 to enter it. Now in this virtual machine, we have some scripts. Now let's say I run one of the scripts, pivots.sh. So what the script can do to try to get out of this virtual machine is to first check if it is running inside a virtual machine. So it can detect, is it in a virtual machine? Then it might want to break out. Then it starts scanning whoever is on the network. So it might find different devices. And then it might try to hack them one by one, which is exactly what happened here. And you'll see if I list the files and folders, we are now in another folder of that computer. So basically we have a backdoor into that computer. We can now, from this virtual machine 1, we can control the other computer, virtual machine 3. So you'll see we have virtual machine 1 and virtual machine 3. If I break free from this, you'll see I actually don't have any of those files in my directory. It is really the other computer. So the way this works is that the script, it detects who is on the network, or well, first it detects, is it running in a virtual machine? If it is running in a virtual machine, it then starts scanning the network using the command ARP-scan. So you can run that command and it will scan whatever computer is on the network. So you'll see different addresses depending on the computer. Then it might be that the malware already spread to the computer or that is badly secured. For example, weak passwords, it might try brute forcing passwords. It might try a web shell or other ways to get access into the computer. Now, so basically the malware can spread itself on the network. Using the network, it can get out of the virtual machine itself. So in this case, it got out of virtual machine 1, and then it jumped into virtual machine 3 by finding out who's on the network and then connecting to it through a backdoor. So you have to keep that in mind with the security of virtual machines, that ideally it is just a standalone machine that doesn't affect any other virtual machines or even your host computer. But in practice, malware these days, sometimes it tries to get out of the virtual machine, out of the sandbox, into possibly other virtual machines or even into your host computer. So you want to be careful with installing random things still on a sandbox, because in theory it is completely secure, but in practice it depends. The malware might try to escape the system, the virtual machine, by scanning the network, by either brute forcing SSH, maybe network shares, or other techniques to break out of the VM. And then from there, it might spread to your entire network. So what you could do is to be not connected to any network, to be on a private network, or simply avoid running any malware in the virtual machine altogether.